Thank you very much, Carlos and Eawag, for the invitation to be with you today. So as Carlos mentioned, my career started in my professional life started in limnology, where I spent time working on lakes and rivers and springs and in groundwater systems. But then for the last years, I've been mostly working on oceans. So much of my content is going to be about oceans, but it's rather generic otherwise. So I hope it will be of interest to a broad audience. And from time to time, I continue to do contributions in limnology. I was actually president of the American Society of Limnology and Oceanography, and now it's called Advancing the Science of Limnology and Oceanography, and I believe I remain the only president that is not working in North America. But I would like to talk today about something that is happening recently, and I believe is an opportunity not for science but for society, which is recognizing natural capital as a new asset class. And I'm going to take you through a journey that starts by climate change, because that's how this asset class starts to be recognized. But then I will talk about the potential and also reconciling this new emergence with more older views of the relationship between, or the role of humans in nature. So basically, as you all know, climate stability in the biosphere has been maintained for a long time through a closed-loop system that is a circular carbon economy that we call the global carbon cycle. And photosynthesis moves about 780 gigatons of carbon dioxide from the atmosphere to the biosphere every year. And then that supports all of the processes that are required to maintain life and ecosystems. There are other contributions of productivity that are not photosynthetic, but photosynthesis is the main path for this transfer of carbon from the atmosphere to the biosphere. And then every year, a similar amount of carbon dioxide is returned to the atmosphere through respiration. In fact, this is such in close balance, that typically we cannot really resolve empirically the difference between global photosynthesis and global respiration, and we need to use models to try to calculate what might be the different or infer imbalances over long time scales. And then this loop, which is the carbon cycle, is a fundamental engine of life that propels living processes in the planet Earth. And then it depends on the abundance of life, which is natural capital. So this couple production respiration loop in the carbon cycle has maintained homeostasis in the atmospheric composition and climate in the planet for a long time, and with within some oscillatory bounds, and that has conferred climate stability, and the climate stability that allowed human civilizations to evolve. So when we calculate the imbalance between productivity and respiration at the global scale, the imbalance is typically less than 0.1%. So it's way smaller than the error bounds of the two metrics. And now we have, however, created a disturbance that have raised carbon dioxide beyond those bounds, between 180 and about 300 ppm in the atmosphere. They have been maintained for nearly 1 million years. So now I think we are at about 420 or 422 ppm, something like this today. And we are clearly beyond the bounds of the last million year. So a simple account of climate change is that sometimes I reflect that fossil fuel burning actually amounts to exosomatic respiration. So it's a way of delivering energy, mostly from contained organic matter, that releases carbon dioxide and consumes oxygen, same as aerobic respiration. And in terms of the stoichiometry and fluxes of carbon and oxygen has the same role. In fact, not only carbon dioxide is increasing in the atmosphere, but also oxygen is decreasing due to the consumption by burning and other processes. And then we have impacted on this not just by exosomatic respiration, but because at the same time, then we have depleted the abundance of natural capital on land and oceans. So we have depleted the capacity of the planet to continue to support production. And then this disruption of the carbon cycle is really what has led to climate change. That's a simplified account, but it is an account that puts this in the framework of metabolic budgets. So the loss of natural capital has occurred both on land and oceans, but if we look at oceans, then we have seen over the last 150 years depletion of the abundance of life across many components. So a reduction in habitats, seagrass meadows, macroalgae, kelp forest, and also mangrove forest, coral reefs, salt marshes, mudflats, oyster reefs, but also the population sizes of many animals, including fish stocks, which are depleted to about half of the original abundance. Also, large whales, probably depleted by 90%, sharks by another 90%, and so on. So to simplify, we have lost about half of the natural capital of the oceans, and in some cases down to we have lost up to 90%. And if we focus, for instance, on the case of whales, this is a reconstruction of whale hunting in Antarctica from 1900 to almost present. So in Antarctica, we hunted down one species after another until we almost depleted them all. And then in 1980, the 1990s, the International Whaling Commission declared a moratorium, actually in 1978. And then hunting came to a much lower value, which is still supported by some nations like Iceland and Norway and Japan, but the values are very small. And the reason why we hunted whales was not to eat their meat, but actually to burn them. So I showed this figure in COP26 in Glasgow 2 years ago, and that shows like a whaling vessel, and they are processing whales, and then a whale oil bottle. And then the reason why we hunted whales was to extract the oil to light the streets of Europe and North America and Australia and other Western nations. So on the right, there is a lamp that is still that is in a street in Wales that used to, in Edinburgh, that used to be powered by whale oil. And when I showed this slide in Glasgow, somebody took the trouble to go to Edinburgh and search this street, and the lamp still there, but now operates with solar power. But in fact, by the time we have depleted whales for power to burn them, then they're already being replaced by gas and coal. So we stopped actually killing whales, not really because we were sorry, but because we found alternative fuels. And then that means that hunting whales is also a contribution to climate change, because what used to be beautiful whale animals were burned, and it's carbon dioxide molecules that continue to create problems and aggravate climate change somewhere in the atmosphere. And it's not only whales, but we have lost about half of the forest of the sea, so half of the abundance of seagrass, salt marshes, kelp forest, and mangrove forests. And then this is of significance because we found, largely through my work and that of other colleagues, that these coastal habitats are the most intense carbon sinks in the biosphere. So basically, when we compare the champion of carbon sequestration on land, that might be the pristine Amazonian forest, with the champion of carbon sequestration on ocean, which will be a Mediterranean Posidonia meadows, then 1 hectare of Posidonia meadow, which looks like a grass, it doesn't look like much, is actually equivalent to about 17 hectares of pristine Amazonian forest in terms of carbon sequestration potential. And I spent some of my research work trying to understand why these habitats are so intense as carbon sinks, and the reasons are multiple, but there were, when I was working with people that were working on forests, there were a number of facts that I thought there was a misunderstanding between what I was doing and what they were understanding. So one of them is that I don't think they were immediately obvious to them that one of the key reasons is that there are no fires underwater. Even though it seems obvious, I think it really took some thinking to realize that that's one of the reasons. So carbon in the ocean accumulates over millenary time scales, and we have done soundings down to 11 meters in the Mediterranean of depth below the sediment, and that is continuous growth of seagrass meadow over 10,000 years, accumulating 11 meters thick deposits of carbon. And this is only because we only went down to 11 meters, but we know that some of those meadows have been in existence for more than 200,000 years. So they have accumulated a lot of carbon over a significant time scales, whereas in forest, this carbon will typically burn due to a forest fire once in a century or something like that, which will be the return time of fire. Also, they're highly productive. Their canopies have a strong role in capturing particles, but also dissipate energy and prevent wave action from resuspending the particles. And their biomass they produce is very depleted in nutrients, so it's very recalcitrant to microbial decomposition, and that is further aggravated because just a few millimeters below the seafloor surface, then there's no oxygen, so microbial degradation processes are significantly slowed down. So all of that acts to render these ecosystems the most important carbon sinks in the biosphere. So losing these habitats also has contributed to climate change through loss of carbon removal capabilities. And now, since 2015, we have the Paris Agreement, which pledges to contain the problem of climate change by achieving a balance between anthropogenic emission by sources and removal by sinks of greenhouse gases by the middle of the 21st century. So essentially what the Paris Agreement aims at doing is establishing a circular economy of carbon that is mimicking and embedding human processes in the way that nature works. So it actually seeks inspiration in how nature manages carbon and reconciles the law of nature with the way we work. So in 2020, my friend Bill McDonough, which actually is the father of the concept of the circular economy, he published a very influential work called Cradle to Cradle, that is the origin of circular economy thinking. And I were tasked with using a circular economy approach to think about ways to address climate change. And we presented in the G20 this very busy diagram, which basically says that we humans use materials in two different domains. We use materials in the technosphere, which is the blue domain, which is the universe of human manufacturer things. And in 2020, precisely that year, then there was a very important milestone in human history, and is that the mass of human-built objects, the technosphere, exceeded for the first time the mass of living nature. So these two spheres are of similar mass, and the blue one is growing faster than the green one, which is actually shrinking. But we need to process carbon in both those domains. And then there are, in a circular economy context, there are different strategies we need to activate. So we need to reduce the emissions of carbon dioxide and other greenhouse gases. We need to reuse and recycle the gases that are emitted, but also because we are operating very close to the threshold and we have accumulated a lot of excess gas in the atmosphere, we also need to remove carbon dioxide that is present in the atmosphere. And there are two ways of doing that. One is to do that in the technosphere, which will involve using machines and other products that remove carbon dioxide, and this carbon dioxide is then removed away or embedded in other products like polymers. So for instance, now I work with a climate tech company that produces climate-friendly concrete that absorbs carbon dioxide rather than emits. So now carbon dioxide is embedded in concrete during the fabrication process. So that is technological fixes to removing excess carbon. But then on the left side of the figure, then you also have an opportunity to remove carbon dioxide through nature-based solutions. And then you see that there's a little diagram where you have a forest. They're all very compact, but you have forests, you have soils, you have also mangroves, and you have ocean, and then at the very left you have whales. So all of the components of nature that may play a role in helping remove carbon dioxide from the atmosphere. So if we zoom in this corner of what we call nature-based solutions, then in that, in fact, that was published in a report from the G20, then Bill McDonough and I define nature-based solutions as a strategy to decarbonize the atmosphere. So that means to remove excess carbon or fugitive carbon, which is how Bill likes to call it, to recarbonize the biosphere. So when you capture carbon dioxide in the technosphere with a direct air capture machine, you are still left with carbon dioxide, and you have to put it somewhere where it doesn't escape. So we don't really know exactly what is the final fate of carbon dioxide. But when we remove carbon dioxide through nature-based solutions, then we know that the product is more life. So it's more biomass of seagrass, of mangroves, of forest. So we know where it ends. And then what we're doing is rebuilding natural capital, of which we lost about half. So that is an important component because it doesn't only address climate change, but also helps to reverse the loss of natural capital. And the scope for nature-based solutions is actually very important because in most people's minds, when we talk about climate change, people really think about fossil fuels immediately, but historically, emissions due to what is called land use change in the IPCC jargon, which is really everything we've done to impact on ecosystems, then is responsible for 38% of cumulative greenhouse gas emissions, still represents about 24% of annual emissions. And that means that in a simple logical term, then there is a potential to address about 1/3 of the problem by activating nature-based solutions. So that really involves rebuilding the abundance of life that we depleted during the 20th century. So in 2020, my colleagues and I published a paper in Nature called Rebuilding Marine Life, where we provided evidence that it's possible to rebuild within limits the abundance of life in the ocean to historical levels, and it will take a number of actions to achieve this and about 30 years or the time span of one human generation. And we also look at what processes led to the depletion of loss and then possibly recovery of marine life. So hunting is the oldest way of impacting on marine life, as I showed in the case of whales. And then fishing pressure was mounting until 1990, and since it has decreased by about 10%. So fishing pressure has decreased a bit globally around the ocean. Deforestation reached a peak also around the 1980s, and now is reducing. Deforestation doesn't directly impact on aquatic ecosystem, but it leads to excess emissions of sediments to the coastal zone, which is a major problem in Southeast Asia and many other regions. For instance, in Philippines, I once sampled a coral reef that was now buried under 1 meter of silt because the adjacent watershed has been logged and is very abrupt, and it had really released a lot of sediments during heavy rains and buried this coral reef. Then we also have habitat loss through different processes, which also peak around the 1980s. And then pollution in the way of chemical pollutants, but also plastics and also climate change are pressures that continue to increase. So we have not made an impact on those two pressures. We have not passed the peak of those pressures, and we are struggling to contain climate change and also chemical pollution. So on the top of this figure, then you have a number of significant policy frameworks that were established, like the International Whaling Moratorium on Whaling from the International Whaling Commission, the Clean Air Act of the US, that then led to the discontinuity of the use of lead-based fuels around the world. And all of those have actually had a positive impact on the recovery of nature, but this is usually not celebrated. But when we look at how these policies impacted on populations and natural capital in the ocean, then we found that it usually takes about 20 years to see the recovery phase. So, but they do work. And they do work, but they need some time to be effective, also because the implementation is not instantaneous, and it takes some time for those policies to achieve the desired scale. So when we recover coastal wetlands like mangroves, seagrass, and so on, then we have an opportunity also to mitigate climate change. And in 2009, I co-authored a report called Blue Carbon, the Role of Healthy Oceans, with colleagues from different UN agencies, and that was presented in the COP of the UNFCCC in Copenhagen. And then that immediately had a significant uptake, but different nations that were involved in mass-scale planting of mangroves, not because of climate mitigation, but to remediate and protect the shorelines against the impact of a tsunami. So Malaysia, Indonesia, India and other nations in the Indian Ocean had suffered about 250,000 casualties in 2004 due to a tsunami, and they were planting mangroves at bigger scales to defend their shorelines from tsunamis, and they hadn't realized that that action also involves significant carbon benefits that they had not accounted for. So it's not only about mitigating climate change, but rebuilding and restoring coastal wetlands also helps to adapt to climate change and protect shorelines. So this is called the Blue Carbon Strategies, and we are now trying to compile all of the projects that are already being executed. So many projects we cannot find the data for, but the level of investment in blue carbon currently is about tens of billions of US dollars, and the committed contributions that we've been able to document, and there are many that are not yet reported, is about 10 billion tons of carbon dioxide removed per year through 78 projects that we were able to document, and then the restoration of about 1 million hectares of mangrove, 1.5 million hectares of mangrove, which imply increasing the global extent of mangroves by about 10%. So that's not a small contribution. So it's propelling both adaptation, mitigation, and rebuilding ecosystems. So the importance of blue carbon strategies for adaptation were always underappreciated compared to the mitigation opportunities, because most of the investors in blue carbon are just taking carbon credits to offset their emissions, and the adaptation benefit is usually not quantified. But it's very, very significant because the population at risk for coastal flooding is very large globally. And the co-benefits is not only adaptation, but there are a whole suite of co-benefits that eventually lead to more adaptive and resilient societies. And in fact, I think that the carbocentric approach to current projects in nature-based solutions is detrimental. And we need to go beyond looking at just carbon, and then looking at natural capital, which is the flow of all these benefits. So blue carbon and nature-based solutions are important and are just an intermediate step towards recognizing the value of natural capital. And there's a perversity in the carbon approach to these ecosystems. And the perversity is that, well, if you want to look at the positive development, is that for the first time, there is economic benefit in investing not in taking from the ocean, but actually in restoring and protecting the ocean. So it's the first time in Western history that this is economically viable to invest in nature. Until now, we could only derive value from the ocean by extracting from the ocean. So a living tuna in the ocean or a living mangrove had no value, but now it was not investable until you log it and sell it for wood, or you sell it as a dead fish. So there's an opportunity to reverse the way we have been interacting with the ocean and generate nature-positive economies by investing in natural capital. And the origin of this problem is the Justinian Code that was finally adopted around year 400 and declared the oceans terra nullius, which means nobody's land, although it's ocean, and also declared marine life res nullis. So neither the ocean nor marine animals belong to anybody. So the first one to capture them was the owner of this asset. And this is the root of the tragedy of the commons that is well known and affects the use of common goods and common resources. But also in the economic development, there was an embedded assumption, and sometimes it was even made explicit, that either nature has zero value or nature is inexhaustible. So because then, therefore, it has no value in the economy because it's always available. So that was a consequence of referring to this as terra nullis and res nullis, but also one of the drivers of the tragedy of the commons. So those are air and oceans that are commons. And in fact, this is not just coming from the paper, very famous, of Garrett Hardin in 1968, called The Tragedy of the Commons in Science. But in fact, Aristotle had already formulated something similar because that translation says that that which is common to the greatest number gets the least amount of care, and humans pay most attention to what is their own, and they care less for what is common. So the tragedy of the common is something that we already knew of for 2,000 years. And then for the first time, we are now investing in living nature, not just taking from nature through these nature-based solutions. And that's a fundamental change in the way society relates with nature. So it's an opportunity to step into blue carbon and nature-based solutions to then rebuild blue natural capital or natural capital both in land and oceans. So that will break through the tragedy of the commons and will shift the conversation from declaring the ocean terra nullius to it being terra omnis, that belongs to everybody, and we benefit from investing in a healthy ocean. And blue natural capital is now becoming a new asset class, and also this bridges the crises of climate and biodiversity and propels both climate and biodiversity action. So in economic terms, blue natural capital refers to the abundance of components in ecosystems, and they can be species or communities or habitats that support the critical functions that deliver the ecosystem services upon which human well-being depends. So that's the definition of natural capital. And then I was talking to a capitalist that is actually the son of the founder of the Starwood Hotels, and now is the CEO of Starwood Capital. His name is James Sterlich, and he walked me through calculations that show that it's more profitable now for an investor to invest in a forest, be in the Amazon or elsewhere, to leave it alone, than to invest in a forest to log it and sell their products. So he actually told me, and I wanted to capture this in a quote, so I asked him to write a little box so I could accredit him with this statement that in the 21st century, natural capital is the new real estate, because the rolling economy and the return on investment is now becoming similar to investing in real estate. So whereas I framed the conversation to this point on climate change, then we were lacking clear goals on biodiversity until recently, and the COP15 in Montreal then released new goals of biodiversity for the decade. It was supposed to have been delivered in 2020, but due to COVID, it was postponed by 2 years. So the Kunming-Montreal Biodiversity Framework is the first time that we have biodiversity goals that are not only about conserving, but they are regenerative, because basically there's many goals and targets, but the most significant is to stop biodiversity loss by 2030, to protect 30% of land and oceans by 2030, but also to restore 30% of degraded habitats. So that is regenerative, and it's the first time that we have regenerative goals within the biodiversity framework, and they explicitly appeal governments and nations that subscribe the CBD to activate nature-based solutions to the maximum of the possible ambition, because nature-based solutions are actually about restoring. So they help propel the goals of the Kunming Biodiversity Framework, so that therefore linking climate action and biodiversity action for the first time. So when we published this paper in Nature that showed that it's possible to rebuild the abundance of life in the oceans within 30 years, then we also start to look at what are the climate benefits of these processes. And we were inspired, for instance, by seeing that even great whales, so when the International Whaling Moratorium was established in 1978, the reason for that is that many species have arrived to the brink of extinction. So the humpback whale was down to about 200 animals in the global ocean, and in the eyes of all scientists, they were actually earmarked for extinction. And yet, due to this moratorium, then we have seen a rebound of the abundance of humpback whales, and today we have about 60 to 80,000 humpback whales in the ocean. So it's 400 times what we had in 1978. They have been expanding at an amazing growth rate for an animal this size of 10% per year. And what we have today in the ocean is about 50% more. The first estimate that we have, which is from 1940. So if we're able to rebuild the abundance of an animal like this, then what can stop us from rebuilding the abundance of everything in nature? And just the abundance of this animal because of the sheer size. So one of these whales is equivalent in size to about 180 trees. So then rebuilding 60,000 whales also carries a significant benefit in terms of carbon that is now, again, leaving carbon rather than be carbon dioxide in the biosphere. So a friend of mine called Ralph Shami, that at the time he was an economist in the International Monetary Fund, then he had a random encounter with a blue whale and was totally mesmerized and started to get interested in that animal and what it does, and then calculated that the recovery of great whales in the ocean can sequester about 0.8 petagrams of carbon, so about 2 petagrams of carbon dioxide per year, and that if you were to calculate the value of whales in terms of the carbon it sequesters directly by embodying carbon in their biomass, but also indirectly, but maintaining the ocean in a high productivity state, then the value of a whale will be about $3 million US. Whereas if you kill a whale and sell it, the market value is about 15,000. So he started, based on this calculation, he started to develop nature positive economies. Again, these values are based on a back of the envelope calculation, so the empirical evidence to confirm these numbers is still to be developed, but I have a project in Antarctica where I'm going down in sediment cores using a qPCR to calculate past abundances of whales, also krill, and carbon sequestration and past productivity to look at the impacts of the hunting of whales on ocean productivity, and then try to test these numbers and then also generate more precise numbers on the impact of whale hunting on carbon sequestration. So in fact, it's not just about whales, but most large animals, most megafauna in the ocean, then are part of what we call an active carbon pump, which has been neglected by geochemists, which think that or assume that carbon only sinks passively in the ocean, but carbon is moved around in very large amounts actively by animals. And then we have now estimates that indicate that the active carbon pump today is about similar in magnitude to the passive carbon pump, which is the sinking of phytoplankton carbon through through gravitational processes in the ocean. And yet we have lost a lot of this biomass. So if we were to recover this biomass, we could probably activate the active carbon pump to be more significant in terms of the contribution to carbon removal. So as I mentioned, the Kunming-Montreal Biodiversity Framework, by being for the first time setting regenerative goals for biodiversity, then connects explicitly the UNFCCC with the goals of biodiversity, and the connection between those two is around blue natural capital, or natural capital green and blue, on land and oceans. This is what connects the two frameworks. And now we need to use the goals of those frameworks to rebuild natural capital. So last week I was in Barcelona. There was a conference of the UN Decade for Ocean Science. So we translated what the goals of the Kunming-Montreal Biodiversity Framework for corals. So there's near loss of biodiversity by 2030 in this case of corals, restore 30% of corals by 2030, protect 30%, and halt human-introduced extinctions. And we put some numbers around that. I think it's a little messed up because of fonts probably, but we calculated that we will need to restore about 780, actually 900 square kilometers of coral reefs globally to achieve the goals of the Kunming-Montreal biodiversity goals. That seems to be impossible because the largest project today is 1 square kilometer, so we have to do 900 projects of the maximum size today to be able to achieve this goal. But in fact, we have calculated that there are 1.5 million coral reefs in the ocean, and the median size is 3 hectares. So if we translate and distribute these 900 square kilometers across these 1.5 million reefs, what we need to restore is 77 square kilometers of coral reef in each reef. So 77 square meters is about 1 tennis court. And then if I was motivated, and I am, then I could get together with my friend on the weekend and then restore the coral reef that we are passionate about. So usually every talk about coral reefs starts by saying that about half to 1 billion people livelihoods depend on coral reefs. So that means it's only 1% of those will be motivated enough to engage in restoration, then we could achieve the goal, because it will take 2 persons to restore 77 square meters in a reef in a year. So when you look at the bulk numbers, everything seems impossible and is discouraging. But when you translate those numbers to the human scale, all of a sudden, then it is possible. Again, we cannot hide the challenges because when we translate this into how many corals we need to put back in the ocean, this is about 126 billion coral colonies we need to put back to be able to achieve 30% restoration and compensate for the corals that may be lost between now and 2030. And the cost of bringing a coral colony to the ocean, when you integrate all of the workflows, is about $20. So that means $600 billion to achieve this goal, which seems impossible. So we're working towards, I'm also the executive director of something called CORDAP, that is the Global Coral R&D Accelerator Platform. And our goal is to restore and conserve coral reefs far more effectively than we can do today with new science and technology, and also to bring down the cost from $20 per colony to $1 per colony. So that's what we're doing. And then in addressing these challenges that seem impossible, then I often think about Stoic philosophers. So one of them, I'm going to quote two. So one is Marco Aurelius, that was a Roman Stoic philosopher that wrote that the impediment to action advances action, and what stands in the way becomes the way. So once you have a goal, and you have to have a positive goal, and the goal seems impossible, and you analyze why it is impossible, then that roadblock becomes the way of addressing your goal. The second philosopher, Stoic philosopher, is a woman called Joan Baez, that was a Hispana singer recently, but she wrote also that action is the remedy to despair. So many of my colleagues have given up because they have been presented with projections that we are going to lose coral reefs. In fact, there's a lot of granularity to those projections when you dive into them, and they think that it's hopeless to try to do anything. But what we need to do is to analyze why we cannot do it, and then try to resolve that problem. And then I've been sometimes accused, actually, by the Deputy Secretary of Commerce of the US of what I pledged that I want to do with corals is impossible. And then I said that it is precisely the reason why we need science, because we use science to redefine the boundaries of the possible. So that is what we need to do. We need better science to be able to do what may seem today impossible, and corals across all components of the oceans are the hardest component to rebuild. So this paper published in Science is actually extracted from the first joint report of the IPCC and the IPBS, which is the equivalent to the IPCC for biodiversity. So we had a one joint mandate by both the CBD and the UNFCCC to look at the synergies and interactions between climate and biodiversity, and we produced a framework of how can we rebuild biodiversity and rebuild habitats while also helping address our climate goals. And we also flagged approaches to mitigating climate change that may generate unintended consequences on biodiversity. And then, for instance, metal-rich electrification carries significant risks, not only because of the high demands for metal extraction, that is now the pressure to engage in deep sea mining, but also because we don't have today a reliable model to recycle lithium batteries. So it's an emerging crisis of pollution from batteries that is brewing on electrification in the energy transition. So we need to be aware of those unintended consequences and be able to reconcile human economies with healthy oceans and stable climates. So I'm coming to a conclusion now, but I will present you with a project that I think is of importance. So we are approaching a paradigm shift, and I have written an article where I submit that planetary repair may be the goal of the fourth industrial revolution, and might be the activity that activates the economy in an acyclical manner by rebuilding nature, creates jobs in a sustainable and meaningful wealth, and leaves a legacy behind, not of abandoned warehouses. I understand that this area here used to be an industrial complex in the past, now reconverted into academic research institutions. But the legacy of the fourth industrial revolution will be healthy planets that are able to support the well-being of generations of humans to come. So that will be about rebuilding our lost natural capital. And that requires that we bring natural capital to markets, that we create positive economies where investing in nature becomes possible by financial markets. So that requires a transition from carbon to natural capital credits. Many of my colleagues talk about biodiversity credits. I think it's a big mistake to try to piece biodiversity into carbon, life into carbon, biodiversity, coastal protection, food security. Because, for instance, if you already have a carbon project for a forest, and now you want to do biodiversity credits, you cannot sell them anymore, because the action against which you sold the carbon credits are restoration and conservation. So you already committed to the actions that will deliver the biodiversity credits. So when you, rather than try to piece out nature, keep it as a single object, which is natural capital, then you can have projects that are based on natural capital, where you can have a higher value for the projects, and the project includes carbon, like climate benefits, biodiversity benefits, even water, hydrological benefits. There's some projects on reforestation that are motivated by stabilizing water cycles, and then also food security benefits. So then we need to create a universal that is transposable metric for biodiversity, which is much harder than carbon, because a ton of carbon is a ton of carbon everywhere. So doing that right and getting consensus in the scientific community and markets around those metrics is very important. And we need to have robust governance mechanisms, financial mechanisms, and market mechanisms to regulate these new market, and we are advocating for the creation of a global natural capital bank. In fact, in May last year, we were invited to spend, my colleague Ralph Shami and I, spend one full day in the headquarters of the European Central Bank, ending with a 1-hour meeting with Christine Lagarde to discuss the importance of investing in nature as a hedge against inflation. So now they actually have created a unit of biodiversity and nature in the European Central Bank, and they're looking at the value of investing in nature to stabilize economies. So this is within our fingertips, and it will be a very significant development. But I just come here from a journey that started in New Zealand and the Cook Islands. And in New Zealand, I served as the chief scientist of a project called Hinemoana Halo, and it's a project a project led by the Maori, so all 13 tribes of Maori, which are indigenous people, but they're very sophisticated. So they are not in a global south country, they are in New Zealand. They work closely with scientific institutions, the equivalent of Eawag in New Zealand and others, and they also themselves are highly educated. But they still are indigenous in their values and culture. And now, after decades of litigation with what they call the Crown, which is the government of New Zealand, they have acquired rights to significant expanse of land and ocean. And now they have consolidated those rights, which include about, I think, 35% of land and a significant fraction of ocean. Now they're going to engage in healing, what they call healing nature. So they have developed a huge project that is a natural capital project, is not carbon or biodiversity. And they're going into markets with this project. And they have not stopped in New Zealand, but they have engaged all of the Polynesian nations, which they recognize as their brothers and sisters around Polynesia, and then gone beyond, and they have done also agreements with Native Americans in Alaska, British Columbia, and Inuit in the Arctic. So this is a project that involves all of the indigenous nations that have some rights against parts of nature to heal their nature. So they start by saying that the Maori of Aotearoa, which is New Zealand, believe that everything is interconnected, land, oceans, and life, and that we, them, are one with nature from which we take and give back as custodians of nature. So they don't see themselves as being outside nature, they see themselves as natural capital themselves. So it is a very different value proposition, and one that is very intrinsic and inherent to their culture and values. So the project involves, for instance, reforesting New Zealand. So I don't know if you have done work in New Zealand, but it suffers strongly from erosion. So some of the watersheds in New Zealand has the highest rates of erosion, and that not only degrades forest, but eventually impacts on aquatic ecosystems. So they see that continuity from watersheds to ocean. So there's not forest or oceans or lakes. They see that as all connected. They recognize that everything is interconnected, and they embed that connectivity in the way they think about the projects. So 75% of forests were lost since European colonization in 1840, with huge impacts. And then only 23% of New Zealand still has some sort of native forests that suffer from fragmentation, extinction of species, and erosion. So the project goes from mountain to ocean, and it has three different components, and it doesn't stop in the shoreline. It goes all the way into the great whales of the ocean, which they recognize as their ancestor. So the Maori think, well, they don't think, they have 26 generations before them as their ancestors, and they are all recognized in their traditional houses. And the 26th generation up is a humpback whale, which guide them into colonizing New Zealand, and for them is family. So this is a project that activates natural capital at a huge scale across the Pacific, increasing natural capital, increasing cultural capital, which is embedded within nature, increasing social capital because the benefits are distributed across all of the indigenous people, and also increasing economic capital. So it's a win-win for people and the planet. And then I was in the Cook Islands 3 weeks ago in a ceremony where the Maori king, which is the gentleman sitting on the top, then signed along with other indigenous leaders. So you have here the king of the Cook Island indigenous people, sign a declaration granting personhood rights to great whales. And that was covered in the New York Times, and I was in an interview with CNN 2 days ago about the significance of this. So the last slide you can't see because this is stopped, but the last slide is about the journey of the Western civilization into increasingly detaching ourselves from nature, and then having a flight of Icarus too close to the sun, and we got burned. And actually now we're getting burned literally with climate change. So now we are in a journey where we're starting to realize the value of nature. We're starting to realize that we are not the touch of nature, but we should be within nature. We should develop our operations within the laws of nature. And we need to learn, again, from indigenous people. And when I work in the Arctic in Canada, there was a nice concept that I liked, and I share with my Maori colleagues, which is in Canada, when you work in the Arctic, because we don't have all data from the Arctic, then you really recognize the value of the traditional knowledge of Inuit. And the way they are reconciling Western and indigenous knowledge is by referring to two ways of knowing. So there were two ways of knowing, which is Western science and indigenous knowledge. But I think we need to be humble and recognize that indigenous knowledge were right for about 2,000 years when we refer to them as savages that did not have something. And even in the case of Australia, we being Westerners, even doubt their human nature. Thank you.